Chapter 6, it's a shorter chapter. It's got 6.1 and 6.2. 6.2 is looking at factors that can speed up or slow down chemical reactions. 6.1 is types of chemical reactions. In fact, if last unit was types of chemicals, this unit is types of actual chemical reactions. It's going to involve some memorizing, but thankfully for the most part, the names they give stuff kind of make sense. They are large vocabulary words, but I think they're in the grade 10 realm. So 6.1, what we want to do is start to categorize certain types of chemical reactions. In particular, there are going to be 6 types of reactions that we're going to learn about. The first type is a synthesis reaction. Now that is a long word, but I think it's a word you've seen before. And this is joining two chemicals to become one compound. And we're going to repeat this in more detail a bit later. So synthesis is putting two chemicals together. What do you think decomposition might be? Taking two chemicals apart. And Matt, do you see what I meant by, like, the words are long, but they sort of make sense. To synthesize something does mean to build or put something together. Decompose, break apart. Then there's something called a single replacement. That's where we have one element in the compound is replaced. How many elements are replaced? One. Can you figure out from the word or the name single replacement how you can remember that we're talking about one? And what's happening to that one element? It's getting replaced. Can you figure out how from the name single replacement that it's getting? So this name makes sense to me. There's a single replacement, and then there is a double replacement. Two compounds swap elements, trade partners. In fact, it's very, very similar to neutralization that we looked at last unit, where you had an acid and a base, and the metal from the base and the non-metal from the acid joined partners, and the H from the acid and the OH from the base became water. That's actually technically a double replacement reaction. And we're actually going to write these out in, like, using X's and Y's and like in algebraic pairs to wrap our brain around them a little easier. Oh, speaking of neutralization, we're going to revisit it. Neutralization. Hey, I already learned about that. Acid and a base form. Who remembers from the last chapter, what do an acid and a base, when you combine them, what do you get? Yep. Salt and? Yep. You guys are okay if I always abbreviate water with H2O because it's less writing? And what was a salt? A salt was the product of an acid-base reaction. It was a metal and a non-metal ionically bonded. Seething plan still going around? Okay, good. And then the last one is a combustion. What does the word combustion mean? Again, it's a big word, but I think you've seen it before. Not quite explodes. Tone it down a bit. Just burns. Okay, although an explosion is a very violent, quick form of a combustion reaction. Hydrocarbon burned in O2. You need oxygen for fire. And then the products when you're burning are always carbon dioxide and water. Do you have something to write with, my friend? Could you borrow that permanently from her and give it back to her at the end of class? You can fill this out as we go. Could we figure that out sooner next time? Thank you, my friend. Merry Christmas. Okay. These are the 6 types. And I think I've done my naming rant. If I haven't, I will later on this year. This is one of the times in chemistry where I think the names kind of make sense. Combustion, yeah, burning. That word means to burn. Synthesis or decomposition, single replacement, double replacement. Those names, Sage, I almost understand what they mean before you give me the definition. But let's look at each of them in more detail. So in the synthesis reaction, 2 or more reactants combine to form one product. If I wanted to generalize it, Jaden, I would say this. A plus B combines to form AB. Except I have to do the crisscross and balance it properly. So here are some examples. Na plus Cl2. What's Na? What's Na? Sodium. And why do I have Cl2? Why don't I just have Cl? Mr. Hofbrinkel, we said chlorine always wants to be in a pair. So first of all, if I was trying to, if I was trying to predict the product, well, this is a synthesis reaction. You are going to get sodium combined with chlorine. First, I would have to crisscross. So over here in the margin, I would go Na. What's the charge on Na? Plus. What's the charge on Cl? Oh, these ones crisscross perfectly. So I would say I know what the product is. It's NaCl. And now I would balance. We're going to try and do this one, Tyra, showing no work. We're going to try and balance this one on the fly by asking what's not balanced right now. How could I fix that? How many Cl's on the left? 2? How many on the right? Well, how can I give myself 2 Cl? Now, what I can't do, I can't add subscripts because that doesn't work as a chemical. Where can I put a 2? Right there. Now what's not balanced? Nah. Oh. 2. And in our notes this time, I'm going to push you to try and balance them up here. I don't do that on a test, Andrea. On a test, I still make a list of everything. But let's see how good we can get. By the way, what is NaCl? I wrote, this is what? I know it's sodium chloride, but what is it? Yeah, it's table salt. N2 plus O2. Oh, why N2? Oh, yeah, Mr. Hofbrinkel. O2, Mr. Hofbrinkel. Now, this one here, covalent or ionic? It's going to be covalent. Now, I still use the crisscross. So what's the charge on nitrogen? 3 minus. And what's the charge on oxygen? 2 minus. That's a 3 by, oh boy, that just got worse and worse. So it's going to be N2O3. What would we call this? It's covalent. Yeah. Dinitrogen trioxide. I think, and I have to look this up. No, never mind, I take that back. I was going to say I think it's nitrous oxide, but it's not. Dinitrogen trioxide. Very quickly, on your own or with your partner next to you, try very quick. These are all synthesis reactions. A single element plus a single element forms a compound. Try doing the crisscross and balance. Try doing these 5. And then if you want to, on the next page, you can identify with a check mark or an X which of these is a They're also called combination reactions. The reason they're also called combination reactions is synthesis is tough to say without spitting. I apologize. Duncan's got the protective shield up. He's a wise man because every time I say synthesis, duck and cover. So try balancing these. I'll do them up here if you get stuck. And then on the next page, put a check mark or an X whether they are synthesis reactions. Don't overcomplicate it. So I'll do 1A with you guys since some of you are looking kind of out of it. I'm going to combine Mg and N2. Tyra, what's the charge on magnesium? I can't. Is it 3 or plus or 2 plus? I have an answer. Oh, I didn't balance it. I'm sorry. You're right. You're right. What's the problem here? Courtney, I'm sorry. You're right. What's not balanced? What's the problem? Oh, how am I going to balance that? Where? Which, there's several, left side or right side? Okay, you're saying put a 2 there. That gives me 6. Keep going. I got to put a 3 there. That gives me 4 nitrogens and 6 oxygens on the left, 4 nitrogens and 6 oxygens on the right. Is she right? How many? No, what's right there? 2 times 2 is? How many? 6, 4, and 6. Thank you. Okay, let's try these here. So, sorry, Tyra, what was the charge on magnesium? 2 plus. And what's the charge on nitrogen? Was that 3 minus? Okay, so they're going to form Mg3N2. And now I have to, oh, this one's easy to balance. I think. Try doing B, C, D, and E on your own. I'm going to do them up here if you get stuck. Again, check with your neighbor if you get stuck as well. I'm going from memory, so I may crisscross wrong. We'll see. Who's calling my beloved name? Looks like your buddy, but next time go during lunch. Six. I think that's right. CD is cadmium. What the heck is the charge on cadmium? That I have no idea. 2 plus? I've got the basic ones memorized, but the rare ones I don't. So this is going to be oh, that one balances already. Cesium. Is it cesium? It is. Oh, plus. I should know that. Phosphorus is. So I'm going to need 4 of those. And I guess that, holy smokes. Is that right? So I got, after crisscrossing, I got this. I hope. Yeah? After crisscrossing, I got these. Okay, and if you didn't finish, I'll post these online. But that's about the speed you want to get to. Question, Allison? Oh, sorry, thought I heard my name. Question 2 is on the next page. So question 2 simply says, with a check mark or an X, Yes or no? And what? By the way, eventually you'll learn 6 different reactions, and Sage, I'll give you a bunch of equations, and I'll say identify the type of reaction. So for a synthesis, I'm looking for, is it one thing plus one thing equals both of them combined? Yes. No. Do you know how I can tell at a glance? How many products are there on the right-hand side? 2. 2. Nope. Yep. What, 2 compounds on the 2 elements on the left form. Yeah, we're turning the page now, Ty. You with me now? Yeah. Okay. And yep. Those are synthesis or combination reactions. Reaction type number 1. Decomposition. That's going to be the opposite. The opposite of a synthesis. This is breaking down a compound into smaller compounds or single elements. If a synthesis is A plus B gives AB, decomposition is AB turns into A plus B. It's the opposite, Con. It's the opposite. Let's erase those instead. So I can break up table salt into Na plus Cl, and this is wrong. Where have I made my mistake in my products? Can you see it? Cl is Mr. Hofbrinkel. There has to be 2 of them. There's always going to be 2 of them if it's on its own. Now I balance. How many chlorines on the right? 2. How many on the left? I better have 2. Lump. And Ty, what's the one more thing I need to do now? That would be wrong. That would be right. Right? We don't change subscripts. The subscripts come from the crisscross rule or Mr. Hofbrinkel, but then we can't muck around with the subscripts at all. H2O. This one is just becoming big. I just read recently they may have found a better way to turn water into hydrogen because hydrogen fuel cell buses run on water, but right now they're not very energy efficient. It takes electricity to split up water into hydrogen and oxygen, and right now, as I understand it, it takes more electricity than you get when you burn the hydrogen back. But I heard they just made a breakthrough recently. We got lots of water. Anyways, it's going to form... why is that wrong? So it's going to be H2 and O2. So how would I balance this one? Sure, Matt. Mr. Smith. How could I balance this one, my friend? How many oxygens on the right-hand side here? How many on the left-hand side right now? How many do I need? So I'll put a 2 there. What else changed? How many hydrogens are on the left now? Put a 2 there. Now there's 4, right? And I wrote here, you need to know the diatomic elements, so you need to know hydrogen, oxygen, fluorine. It's Br, by the way, it's bromine, so even though I treat it as one word, Brinkle, it's not a capital R. Iodine, nitrogen, chlorine. Those are the diatomic. Oh, and you saw in the video that I showed you at the beginning of class, nitrogen's diatomic bond is particularly strong because it actually bonds with itself with 3 separate covalent bonds, which is why it's a good explosive. Says complete and balance the following composition reactions. Remember to check for diatomic elements as you write the formulas. You know what we're going to do? We're going to do A, C, and E together. So AuCl3, it's a decomposition reaction. So Allison, the first thing I'm going to say is it's going to break up into Au and Cl. Is that okay? Then I go check for any Mr. Hofbrinkels. Are there any Mr. Hofbrinkels? Okay, I need to put a 2 there. You okay with that, Allison, so far? Thumbs up. And now, Joseph, we balance. Folks, how would I balance this? Any suggestions? Where would you start? What are you going to start looking at? The AU or the CL? The CL. What's yucky? Well, you know what? I want to turn them into 6s, I think. Is that right? You spotted that little shortcut? So I'm going to first of all put a 3 there. That gives me 6. I'll put a 2 there. I got to change one, or got to fix one more thing. 2 in front of the AU. There. Hey, you did that so well. Let's just skip to E. CSI, not the TV show. Okay, it's 2 elements. It's going to break apart into, this is a decomposition reaction. CS plus I. Any of these belong to Mr. Hofbrinkel? 2 of those. Okay, so what's that mean? I need 2 of those, right? Oh, and 2 of those. So I'm saying, Matt, hopefully you're at the stage where for a not very complicated equation, you can balance it on the fly. And if you can, I say, go ahead, I give you permission. I probably would still show my work on a test or a quiz. But in your homework, if you have a balanced equation, I'm going to assume now, Jaden, that you didn't just cheat and copy. Now, if you're dumb enough to cheat and copy, you're going to have to know how to do it on the test. It's going to cost you marks. So that's my way of also saying learn it. Identify each reaction as a synthesis, decomposition, or neither. What would a good abbreviation be to use for a synthesis? Capital S. What would a good abbreviation be to use for a decomposition? D. What would a good abbreviation be to use for neither? I'm not going to do N because I know neutralization's coming later. I'm going to use an X like it's wrong. So the first one, S, D, or nothing. Breaking carbon dioxide up into its constituent parts. What about here? By the way, what B actually is a single replacement reaction, which is what we're going to be looking at next. Can you see the gold got replaced by the copper? It's a single replacement, and now where copper used to be alone, now the gold is alone. C. C. Lydia. Yep. D. Right now it's nothing. This is actually a double replacement reaction because you can see these two switch partners. It's like going out on an awkward double date and finding out that you like the other person better. I kid you not, that's going to be my analogy, but it's going to be a dumb way to remember it. Taylor's going, date? No, someday. Okay. What about this last one? Well, this is technically a decomposition but you're not completely decomposing it. You're just knocking off the oxygen atoms and you're keeping the sodium chloride on its own. But okay. So we have synthesis, combining. We have decomposition, breaking apart. Single replacement. A single replacement is a single element plus a compound. What happens is the single element bumps one element out of the compound. Oh, and by the way, they stay within their groups. A metal will bump a metal. A non-metal tie will bump a non-metal. Single, one, replacement, swap. Is that okay? We can remember that? We can write this down. If we go to our algebraic one, what we're really saying is this. AB plus C becomes CB plus A if C is a metal. If C is a non-metal. Oh, that didn't erase. So let's try some. Aluminum, if you combine it with copper chloride, and we're going to do a single replacement. What's the single element by itself on the left-hand side, on the reactant side? Aluminum. Okay, it's going to bump off the copper. It's going to join with the chloride. And we're going to have some copper. However, we need to crisscross this properly, because I just put aluminum and chloride together, but I didn't say how many of each we needed. What's the charge on aluminum? 3. And chloride is 1 minus. So if I crisscross, it would be AlCl3 plus Cu. Is that right? Now we balance. Where am I going to start? Where am I going to start? With the chlorines? Yeah, and you know what? I think, again, I'm going to try and turn them into 6s, because I see 2 on the left, Sage, and 3 on the right. See it, see it, see it, see it, see it? So I'm going to try the whole, put a 2 there. Now that gives me also 2 of those. I'm going to put a 3 there. That gives me... I think it's going to be 2, 3, 2, 3. Oh, are the numbers always going to be the same? Probably not. You okay with that, though, so far, Tyler? Thumbs up. Okay. F2 plus NaI1. Here is a single replacement reaction. This one here, by itself, metal or non-metal? So it's going to replace the non-metal. I'm going to get NaF, I'll crisscross in a second, and I2, because iodine is a Hofbrinkel, so there's going to be 2 of them. Oh, if you crisscross NaF, what does it end up being? 1 and 1? So it turns out that one works. Now let's balance. I need 2 of those because I got 2 fluorides, 2 fluorines on the left. Is that okay, Conlon? But what else just changed? How many sodiums do I have now on the right? 2. So I'll put a 2 here. Oh, I think it just balanced itself. Is that okay? Thumbs up. We're just going to do 1E together. Let me zoom in. It says complete and balance the single replacement. You know what? We're just going to do 1E. Now, how can I tell this is a single replacement reaction? Well, it's about the only option. BE, beryllium, metal or non-metal? It's a metal, so it's going to replace the Fe. So first of all, I say, I know what my product is going to be. My product is going to be beryllium is going to combine with NO3, and there's going to be an Fe. I haven't crisscrossed this yet. What's the charge on beryllium, on Be? 2? What's the charge on whatever the heck we call NO3? This is a polyatomic. What is NO3? Nitrite? Nitrate? Nitrate. Minus. So I think I'm going to have, when I crisscross, that. Now we balance. Oh! What's nice about this one? It's already balanced. Okay, I'll take that. Now we have synthesis, decomposition. Oh, why can't I use D for double replacement? Or sorry, we're doing single replacement, right? Why can't I use S for single replacement? How about, can I go capital S, capital R? And nothing. All right, that first one, what kind of a reaction is that? Decomposition. Breaking it apart. What about this next one? What about C? D, single replacement, right? Looks like the chlorine and the bromine are swapping places. Is that okay, Ty? Hey, what about D? Sorry, what about E? Synthesis? So none of these were nothing. Keep going. Oh, yeah. Quickly, bunny. Double replacement. Exactly what it sounds like. Two ionic solutions, usually liquids, react to produce two other ionic compounds. But I gotta be a bit fussier. What happens here, Sage, is you mix two liquids together, you shake them up, and all of a sudden you notice the two compounds that are formed, one is still a liquid, but the other one is a solid. And the fancy word for a solid coming out of this is called a precipitate. Boy, did I spell that wrong. Precipitate. Two T's, right, Mr. Duke? And it's not an A there, it's an I. Good gosh, can you spell that wrong or what? Precipitate. A solid. And I apologize, I was going to have a reaction set up and I was going to show it to you and I forgot to get it ready. But I'll try and get one for next class. You pour two liquids together, shake them up, and suddenly you notice it gets cloudy, and then if you just let it sit, you'll notice on the bottom something starts to settle over time. That's the precipitate, and you've actually combined a double replacement reaction. AB, aqueous in water, plus CD, aqueous in water, gives AD, still liquid, plus a solid, CB. Here's our example. Lead nitrate plus sodium iodide. Okay. This metal is going to join with that. Don't write that down. This metal is going to join with that. So the first thing that I do is I just predict the products. I say, okay, there's going to be a PBI, and there's going to be an NaNO3. Except I haven't crisscrossed yet. But Alex, I know those are the partners. Let's crisscross NaNO3. I'll do that one first. Na is plus. NO3 is, what's the charge on NO3? Please tell me it's a minus. That'd be convenient. Hey, it is. So this, Andrea, is 1 and 1. Do I write the ones? No. PBI. Why is this one tougher? Ah! Lead's multivalent. Wait a minute. Look over here. What must the charge be on lead if I needed 2 NO3s for it to be stable? If I'm crisscrossing. I mean, I know I is negative. What must this lead have been for that to be stable? Had to have been a 2 because each one of these is 1 and you needed 2 of them. So you know what? I can say it must be that. Crisscross, and I get that. This is pretty tough. Now let's balance. Gonna need 2 of those because I got 2 iodines. Oh, which gives me 2 sodiums on the left. So I'll need 2 of those on the right. And, oh, I think it balanced. One lead, two NO3s, two NO3s, two NAs, two NAs, two I's, two I's. Is that okay? Let's try this next one, NaOH plus FeCl3. And it does get trickier when you're dealing with multivalence. Yep. Quick like a bunny. Thank you, sir. We're actually almost done. We're getting close. NaOH plus FeCl3. First thing I do is I say, hey, this is a double replacement reaction, and I write the partners. Na is going to combine with the Cl, and the Fe is going to combine with the OH. You okay with that, Kyle? Then I crisscross. Iron Fe multivalent, I'm going to save that for last. You know what? NaCl, that one's already crisscrossed properly, isn't it? It's 1 and 1 and crisscross, you get 1 and 1. Problem when I crisscross this puppy here is, what's the charge on OH? Negative? Okay. What was the charge on iron? I can figure it out from that. What's the charge on a single chlorine? -1. How many chlorines did we need? 3 for 1 iron. That must mean that 1 iron must have been a 3+. It had to have been a 3+. Now we crisscross, and I get bracket 3 of those. Is that okay, Ty? No? Yes? Got it? This is tricky. Okay? As soon as it's multivalent, much like before, it goes up in level of difficulty quite a bit. Now we balance. Well, the Na matches. You know what? Let's try the Cls. I got 3 of those. I need 3 of those. Oh, but now I have 3 NAs, so I need 3 of those. Oh, but now I got 3 OHs. Oh, wait a minute. There is 3 OHs. There, it balances with a 3 in the front and a 3 at the front. Is that okay? We're going to skip the practice problem number 1, but let's classify. So now we have S, D, SR, and DR. Or nothing. Actually, I think it's guaranteed to be one of these. So that first one, what kind of a reaction is that? Sorry? Single replacement? B. I'll make this a bit bigger so you guys can see. Right? This and this swap partners. What about this here? This is a single replacement. Al bumped the iron. It's like somebody cutting in on a dance or cutting in on a date or something like that. What about this one here? Here's a synthesis. And decomposition. Is that okay? A couple more, we're done. Half the unit. Neutralization. Acid-base neutralization. Well, you already saw this in the last chapter. Rylan, you remembered. An acid plus a base forms what and what? Salt and H2O. How can I recognize that it's an acid and a base? How did we recognize that it was an acid? Starts with an H. How do we recognize that it's a base? Ends in OH. I know it's going to be that. I left a space in front to put a coefficient. And it's going to be CaSO4, but I got to crisscross properly. Let's off in the margin. What's the charge on calcium? Is it 2 or 3? And what's the charge on SO4? 2 negative? You mean these crisscross? Oh, you mean they crisscross nicely and match 1 and 1? Now we balance. 1 Ca, 1 Ca, 1 SO4, 1 SO4. 1, 2, 3, 4 hydrogens. 4 hydrogens. 2 oxygens. Mr. Duick, how come you don't count those oxygens? Because, Jaden, I kept them with the, I think it's a sulfate or a sulfite, whatever SO4 is. I kept them, I treated them as one funky, strange atom, so I don't count those. Here I have 1, 2 oxygens, 1, 2 oxygens. We're balanced. Is that okay? No? No, we're good? We're going to skip number 1, do number 2s. How about capital N for neutralization? Is that okay? Taylor, leave Allison alone. She's trying to learn. Is he bothering you, Allison? I'll give him a detention if you say the word. You sure? Because I can give him a detention, totally. Okay. Try these 4 on your own. I'm going to freeze the screen. Figure out what kind these are. I got they almost got me on the last one. The very last one, I saw the HTCl. I said, oh, that's acid. Yeah. Oh, B is decomposition. Good gosh, I was reading this backwards for some reason. Thank you, Matt. Candy for you. Oh, and I forgot to give the candies out to the people that won the prizes. I'll give that out in a second. Okay. Last one. Combustion. Combustion. Okay, what I'm going to do temporarily is, because I'm not quite going to finish the lesson and I don't want to talk the whole time, but what you can start right now, okay? You can, where it says practice problems, page 265, I typed them out. You can do right now everything except number 5. So try balancing it, predicting the products, and then write what type. And yes, you can use the abbreviations that we've done so far. When I see you guys again on Wednesday, we'll pick up with combustion. I have a whole bunch of practice stuff. I have a take-home quiz and a few other things as well. Oh, and here's a lovely little summary in case you get stuck. And if you're wondering, combustion ends up being that one there. Okay?